everyone! Today, we're going to discuss array data structure and linked list data structure. So what is array data structure? Array data structure is a container which can hold fixed number of items, and these items should be of the same type. In an array, there are elements and index. So what is element and index? First, element. Element is the number that is stored in an array. While in the index, this is the location of the items in an array. And now let's discuss the basic operation of the array. First, append. To add an element to the end of the array. This is example of append method. I will just finish first this program before explain the whole of it. This is example of comment line which explains the whole program. From array import asterisk, this is used to access all the methods that array can do. Array equals array I, 1, 3, 5, 7, 9. As you can see, I used I as my type code and 1, 3, 5, 7, 9 as array itself. For your guidance, go to help Python docs F1 and type array to see the type codes. These are examples of the type codes that you can use in array methods. Array.append 13. This is the process of this program which 13 will added to the last part of the array. And print array is for you to print the program itself. So let's check if the program will run. As you can see, you appended 13 in the last part of the array. There you have it. That is append method. Second, insert. To add an element to the given index. And now, we are done with the append method, and now is the insertion. This is just a copy-paste of the previous program that I taught to you. Let us change first the comment line and the method itself. The insertion method have two given, the index and the item. First, we're going to print the original and the latest which have inserted method. Let's try if the program will work. As you can see, there is a difference between the two. The 13 is now inserted in the index 2. Third, deletion method. To remove an element in the given array. To further understand the deletion method, let's see this program. In deletion method, it is either popping the index in an array or removing the element at all. This program is already set in deleting method. And let us try if the program will run. As you can see, on the result, there are differences between the array. The use of remove is removing the first occurrence of the element, while popping is having a specific index to remove in the array. This is for the deletion method. Fourth, traverse. This operation will print all the elements in an array. This is example of traverse method. This operation will print all the elements in an array. Let's see if this program will print all the elements of it. There you have it, traverse method. Fifth, reverse. This is to reverse all the elements in an array. This is example of reverse method. In reverse method, element in array will change location. Let's see if the array will reverse. As you can see, in index 0 will become the last element, having a last index. And the last element will become the first element with 0 index, or vice versa. That's how the reverse work in array data structure. 6. Search. To look for the item in an array and its index. Second to the last is search method. By using the array count, it is about counting the numbers of times an item exists in the array. This method will determine whether there is 1 or 2 or more repetitive numbers in a given array. Or you can use the square bracket, which includes index, to find the value of it. Now, let's run the program and see if the index and elements are found. As you can see, the program searched the elements and the index. Lastly, update. To change or update your array into new elements. Last is update method. In this part, we will use two methods. First, the pop method. As I mentioned a while ago, pop method is about removing number through index. Next, we will use insert method to update the remove item to a new element by telling the program about the place of the index and the item to be replaced on it. Now, let's run the program and see if the program will become updated. As you can see, the program satisfies and updated based on the third element. This is the last for the basic operation of the array data structure. Terminals, books in libraries, and the tricycle in todas are the examples of array data structure. This data structure is applicable in non-real-life situations because arrangement, updating, and inserting are happening. In the terminals, those vehicles are exiting and entering from the area, which is if we apply in array, it is the deleting, appending, or like inserting. In the libraries, librarians are arranging the books, the titles of every book, or maybe the year when it is being published. From that, we can encounter the array. Let's proceed to linked list data structure. So what is linked list data structure? It is a sequence which contains items and connected by a link. And now, let's discuss the basic terminologies about linked list. Element, a data stored in every link of a linked list. Next, every link of a linked list that is connected to the other link. Linked list uses data structure called a node to wrap one of each element. Every node contains pointers as the address of the memory, or just the node itself. As you can see on the diagram, single linked list contains a link to the other element. When the link is set to null, it is the indication of the last node. While in double linked list, the link can go backward and forward, setting the last node either the left or right. But the linked list always starts with a head in the left and always ends with a null. Circular linked list. In this diagram, last item contains link of the first element as next.
and first element has linked to the last element as previous. It has circular motion. So this is example of linked list. As you can see in this class code, I use self and data. This is the element that needed in this program. Self.data. This part is iteration of data points. Self.next. We're going to store the pointer to the next node. None indicates that the last node will be set into null if the link is done. In the class linked list, which wraps all the nodes to be inputted, self.head is availability of nodes in the linked list. Also, container to allow to place the first element of the list. Define append. In this part, it adds first element or data point in the list. Passing the data of the node will happen in this NN node. This current equals self.head is to store the current variable inputted. In define length, we have another set as a current equals self.head and total, which is equal to 0. This total is the container of the total number of nodes we have seen. After finishing all the iteration, it will contain the number of elements in the list. That's why we need to return total. Define display. Container is equal to empty list. This contains all the list of elements. Current underscore node is equal to self.head. It is creation of new variable that we want to find. Then while iteration will happen, define get. The indices part which we are going to get the data. If indices is to pull all the data point into specific index, this part will happen if the index is out of range. Current underscore index is the variable of index we are looking. Current underscore node is to contain current node itself. If current is equal to indices, this is to know if the current is equal to index that is provided by the user. As we run the program, I name my linked list as my list and I will append my list. As we run the program, we created an empty list, and after appending my list, I get 1, 2, 3, 4, and 9, and I get the second index, which is 3.
Hi guys, thank you for watching. We hope you enjoyed this tutorial. Bye bye.